Why are different electrode types used for BCI hardware? Imagine trying to listen to a whisper from across a noisy room. That's similar to what brain signals can be like when captured by electrodes. The type of electrode used makes a big difference in how well these signals are recorded and how safe the process is. In brain-computer interfaces, or BCIs, electrodes are the key to translating brain activity into commands for computers or devices. There are three main categories of BCIs based on how they interact with the brain. Invasive BCIs involve placing electrodes directly into the brain tissue through surgery. These electrodes can pick up very clear signals because they are so close to the neurons. But they also carry risks like infections or damage to brain tissue. These are mostly used in research or for patients with severe neurological issues who need very precise control. Semi-invasive BCIs sit between invasive and non-invasive. They involve placing electrodes inside the skull but not directly into the brain tissue. These electrodes are usually attached to the skull or embedded in the dura mater, the outer layer covering the brain. They offer a good balance because they give better signals than external electrodes but are less risky than full brain surgery. Non-invasive BCIs are the safest and most common. They use electrodes placed on the scalp or other external parts of the body. These are easy to set up and don't require surgery. Within non-invasive options, there are several types of electrodes. Wet electrodes use a gel or conductive paste to improve contact with the scalp. This gel reduces impedance, which helps get clearer signals. But the gel can be messy and needs to be reapplied often, making it less practical for everyday use. Dry electrodes don't need gel at all. They are designed to work with just contact on the skin, making them more convenient for daily wear. They are less sensitive to movement, which is good for real-world applications. However, they often have higher impedance, which can lead to less clear signals and some signal drift over time. Semi-dry electrodes combine features of both wet and dry types. They use a small amount of liquid or gel to improve contact but requiring less maintenance than traditional wet electrodes. Capacitive electrodes are another option. They don't touch the scalp directly but instead use capacitive coupling to pick up brain signals. This makes them completely gel-free and non-invasive, which is great for comfort and ease of use. Choosing the right electrode depends on what the BCI is meant to do. For medical applications needing precise control, invasive or semi-invasive electrodes are often preferred. For everyday use, like wearable devices or assistive tech, dry or capacitive electrodes are more practical. Advances in materials and design are constantly improving these electrodes, making BCIs more effective and user-friendly. Each type has its strengths and limitations, and selecting the best one depends on balancing signal quality, safety, and convenience.